Okay, hope everybody's doing all right today. Well, let's go ahead and get started. Were there any questions on the assignment? Hey,
Can we go over number 4?
number 4. Okay, let's see here. I believe I got this pulled up. This will let me. Okay, so 4. Okay. Oh, number 3? Okay. All right, let's see what we got here. Two ships leave the harbor at the same time. The first ship is traveling at a constant 16 miles per hour, while the second ship is traveling at a constant rate of 24 miles per hour. If the angle between the courses is 115 degrees, how far apart are the ships after 2.5 hours? Okay, so I already know I'm going to need this, so let me go ahead and get that pulled up, if it will. There it goes. Okay. Now it doesn't give me any specific directions on this one. It just says two ships are going to leave the harbor. So how about I'll go ahead and draw just a coordinate plane here. So let's say this is the first ship, and let's say this is the direction of the second ship. Okay, so the first, the second, and let's just say the angle between them is going to be, what was it, 115 degrees. Okay, we're wanting to find out how far apart they are after 2.5 hours. So this one is actually really similar to that last one we did on the notes, because for ship number 1, what's the length that I would put here? The first ship is traveling 16 miles per hour. Would it be 16?
Well, you could do 16 and 24 and then multiply by the end, or you could
You
do
could, yeah, okay. Yeah, I was thinking let's just go ahead and multiply them now, be done with it. So yeah, distance equals rate times time, so 16 times the 2.5 hours, so they went 40. Okay, 40 miles. And the other one, how fast was it traveling? 24. Okay, so let's see. 24, if it's times the 2.5. Okay, it's going to give me 60 here. Okay, so that's 60 miles. And it looks like I've got a side angle side situation. I want to know the length the ships are apart, how many miles. So it's just law of cosines. So what's going to be the equation that I would write? X squared. Okay. So x squared equals 60 squared plus 40 squared.
minus 2 times 60 times 40, and times the cosine of which 3x, 115.
115. There we go. Okay. And this one is the easiest type. In fact, these are the ones we want to see. We don't have to do any manipulation other than just taking the root of the entire expression. So let's see what we're going to end up with. Square root of 60 squared plus 40 squared minus 2 times 60 times 40 times the cosine of 115. Okay, so after 2.5 hours, they should be about 85 miles apart. Okay. Michelle, does that make sense? Okay. Bless you. Let's see, so X is back. 85 miles. All right, anything else? Number what? 4. Okay, so let's see what number 4 says. All right, so it says town clock has hands that are length 2 meters and 3.5 meters. Find the angle between the hands at 8:15. Okay, and then find the distance between the tips of the hands at 8:15. Okay, so let's see here. Let me go ahead and see if I can draw a decent representation of a clock. Okay, to kind of help me out here. So find the angle between the hands at 8:15. So let's say this is 2, 3, 6, 9. So we got 8. So we're going to have the hour hand. It's going to be like this. And then it's at 8:15. Okay. So find the angle between the hands. So I'm looking for this right here. Okay. Well, how am I gonna? Hey, that's actually a pretty decent clock, man. I gotta say, it's about time I drew something like that. Time. Yeah, okay. Yeah. Yeah, that's a good one. Yeah. You gotta hand it to me. The hands of a clock. So let's see. Where would I go from here? Thank you. Yes, ma'am. Okay. So we know this is 90 degrees right here. Okay. Okay. So actually, how many degrees would be in 5 minutes then? Okay, 15? No, a little more. 30. 30, 30, 30, right? Okay. The only thing I don't remember because, if it's at 8:15, the hour hand would be slightly past the 8. What did I put on my answer? I don't even remember. Did I just go ahead and put 150? 150. Okay. So we'll just go ahead and run with that idea. Um, I wonder how far off that would be because, you would have to expect the hour hand to be a little past 8. I didn't even think about that until right now because they go ahead and tell me that the lengths, this would be 2 and this would be 3.5, and then creating a triangle here, we could go ahead and find that. But yeah, if you just go ahead and divide it up by 5-minute increments, she's right. A quarter would be 90, so 5 minutes would be 30, and then from there to there, I'm looking at 150 degrees. Did anybody want me to actually go ahead and work it out to see? I don't know if that would come out to 150 or if it would actually be a little more. Did anybody actually do the law of cosines, or how many people just did it like that? Okay. Well, there you go. Who asked me about this problem? Okay. So, Ryan, does that make sense? Okay. So now, if we're going to go ahead and say that the angle between them is 150. Find the distance between the tips of the hands at 8:15. Now, this is a throwback problem. The distance between the tips. Oh, actually, no. We're going to start talking about that today. Yeah. So all I got to do is find X right here. There we go. So actually, yeah, we can just go ahead and do exactly what we did on the previous problem with the two ships. X squared would equal what? 2 squared plus 3.5 squared. 2. Cosine of 150 degrees. And then just like before, no manipulation. We just have to take the square root. There we go. Okay, and let's plug it all in. So square root, I'm just going to go ahead and say 4 plus 3.5 squared minus, I'm just going to go ahead and say 4 times 3.5. Take care of a portion of it. Cosine 150. Okay. All right. So I'm getting about 5.2. What was the unit of measurement they had here? Meters. Okay, so about 5.2 meters, or 5.3, excuse me, meters from each other. Okay. Right, is that good? Yes. Okay. All right. Ooh, that problem just flew by. I know. Math, we're always having fun, right? Yeah. I like that. Yeah. Okay. Anything else? Law of cosines want to talk about? No? Okay. Well, good, good, good. If you do end up having any questions, let me know. Remember, what's happening next week? You got the exam that's coming up on Thursday. The good news is you don't have any written homework for the weekend, so good opportunity. Take out your notes, go ahead and look over them. If you do have any questions next week, let me know. But it's going to be right triangle trig, the law of sines, law of cosines, and we should be able to finish up this geometry unit by next week. And I'm thinking we should be able to start our final unit of the year, the last week of the 6 weeks, introduction to calculus. Hey, thanks, sir. Okay, so let me go ahead and shut this down. You want to save changes? One. Okay, don't need that key anymore. And here we go. So this lesson should not take a whole lot of time. This is just review. Okay. just geometry, area, perimeter, circumference, all that good stuff. So let's see how much we remember. And because we're going back into geometry with figures, I'm going to start off with a joke. Okay. What did the little acorn say when he grew up? Geometry. 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 You always want to start with, okay, there we go. All right, so here we go. Perimeter and area. We've got all kinds of different figures. The perimeter of a figure is the measurement of the distance around its boundary, the sum of all the sides. Area, the area of a closed figure is the number of square units that it contains. And you've got all your old formulas right here from triangles. Here it's called trapezium, but we call those trapezoids. Half the base times the height, half the height times the sum of the bases, area of sector. How far did you guys go in geometry with sectors? Did you go any further than just area and like the arc length of a sector? Did you actually work backwards after the trig unit to find the angle measure, or was it just pretty standard? It's been a while, I imagine. I don't know if you remember.
I think I remember going back.
You did go back? Okay, okay. Well, good, good, good. So like I said, this all ought to be pretty quick. Let's just start doing some problems and see how far we get. So number one, find the perimeter of the following figures, and we have several. So, and I can go ahead and throw some FYI information in there for you like I normally do, because who doesn't want that, right? Because it's been so long since you've seen geometry, you're like, I want to remember everything about it. Okay, so what do we call a triangle where all three of the sides are congruent? That's equilateral. So that means this triangle is also 66, so equiangular. And I believe we mentioned it in here some time ago. What do we call a figure that is both equilateral and equiangular? Regular. We call that a regular figure. Yes. Very good. Okay. Well, we know these tick marks indicate congruence. So what would the perimeter be? 3x. X plus x plus x. Simple, very straightforward. Okay, then we have a quadrilateral right here. Okay, it's a trapezoid shape. We don't know that x and x plus 3 are parallel. They would have to be if we're going to classify it as a trapezoid. But regardless, let's see. How many x's do I have? Okay, so I heard 3, 4, 5. 5, okay. So 5x's total. And luckily those two are opposites, and then plus 5 units, whatever it is we're measuring in. Okay, perimeter, remember, is simply just the sum of the sides. When we start getting to circles, perimeter is just known as circumference. Okay, and there was a couple formulas there. So we have this figure here. So can anybody tell me what's the sum of the sides? How many x's do I have? So I got 3 x's plus how many y's? Okay. 2, 2, 3, 3, 3, 2. Okay. 3y. And then plus 3.
Just have weird signs.
Yeah, that's all right. No, that's okay. 3, 3, 3. You know what it reminds me of, since we're going into tax season, those commercials? Free, free, free. Free, 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 free. You know the commercials that make you want to throw a brick in the TV? Okay. All right. So find to 3 significant figures the perimeter of, okay, so we have a semicircle. All right, so first off, what's the circumference of a circle? Okay, so the circumference is equal to pi d, or you can go ahead and say, oh, I got you. Or 2 pi r. Okay, whichever one you wanted to go ahead and use. I would probably go ahead and use the pi d, because we actually have the diameter. Okay, so walk me through this. How would you like me to do it? Okay, so doing what first? There you go, because we don't have the full circle. If we go ahead and use the, just pi d would give me all the distance around. So 10 times pi would give me the full circumference. I'm going to go ahead and divide that by 2. So I'm looking at 5 pi, but then I want to what? Remember, that's only going to be from here, the top half, and then we're going to make sure to add the 10. Okay. All right, because we don't want to forget about the diameter. So 5 pi plus 10, let's see what we end up with. Oh, I don't want the comma. I wanted pi plus 10. Okay. All right, so it says to 3 significant figures, so what would I put? 25.7. And do we have a unit of measurement here? We do. Okay. So I would say 25.7 centimeters. Perfect. Okay. Now this next one does not look like it, and hopefully the first thing you were taught in geometry was to never trust the diagram, because the diagrams are never going to be to scale. So this one, it does not look like it, but that is another semicircle, okay, where we know the diameter is going to be 6. Okay, so it looks almost like an ice cream cone turned sideways. All right, so how do I start? Just do it. Okay. Well, let's start with the side lengths. So we know both of these are going to be 7, so that at least gives me 14, right? Plus, okay, so we have the diameter again. So remember the circumference was pi d. So I'm going to go ahead and say 6 pi and then divide by 2. There we go. So really I'm looking at 14 plus 3 pi for my perimeter. I'm sorry? Now we don't have to include the 6 because we want the perimeter. On this one, the diameter was part of the perimeter, but here we're only going around the outside. Okay. So let's see here. 14, what did we say, plus 3 pi? Okay. There we go. Okay. So I'd say 23.4. Okay. So 23.4 centimeters. Okay. And this looks like a little track you might see at a field someplace. So basically it's a square with a circle cut in half and just spread on those sides. All right. Would anybody want to come on up and help me with this one? John, you want to do it?
Yeah.
Okay. All right.
Do I need to put the pi symbol?
We will need to use it in our calculation. Remember, we're trying to find perimeter, though.
Oh, I accidentally got area.
Yeah, if we were doing for area, that'd be perfect. Okay, so the 12 takes care of the top and bottom of the box.
Radius.
And what do we know about the 2 semicircles? There you go. We just need to find the circumference of the full one because they have the same diameter. There we go. So what formula would you like to use, sir? 2 pi r or pi d?
I'll do pi d. So
Pi d. Okay, so 6 pi.
Can we pull?
Oh, yeah, absolutely. Okay. So that's okay. So you want to go ahead and multiply 6 times pi. Okay, so 18.85. And then what do we need to add to that?
We need to add to 12.
12. There we go.
So it should be 30.8.
There you go. Okay. That's exactly right. 30.8. What are we talking about here? Meters. There we go. Okay. Perfect. Okay. The good old days of geometry kind of coming back to you. Okay. Easy. Okay. This, like I said, this apologize. It's just stuff. These are potential problems that could show up, but also it's very progressive. The next unit is going to be on nets and prisms, and that's where you're going to be asked to find a diagonal of a prism, slant height, surface area, things like that. And all of those, stem from these easier formulas. So we just wanted to go ahead and take some time to review those. Speaking of, here are the different types of prisms we'll be looking at and all the corresponding formulas. volume, surface area. Now it's not listed here, but what's lateral area? Okay, but it doesn't include what? Because the lateral area could be faces. Because like on a rectangular prism, you could technically say you have 6 faces. Okay, so it's the surface area that does not include the bases. How we would name the prism. You guys remember that? Okay. Okay. And you got all kinds of different shapes here: cylinders, wedge, cone, sphere. You go. Really? Nothing? I don't know. Actually, I have kind of a interesting story. When I first started teaching 16 years ago, so basically when you guys were very, very little, like little babies, or depending on when you were born, one of the first courses that I was asked to teach here was geometry. And, there's a unit over this stuff. And I tried to get very creative as I could when it came to like nets and prisms and things of that nature. So I came up with this really cool activity where we would take bubble gum. Okay, we took a bunch of toothpicks and we would actually construct the prisms that we were dealing with. And then I had a bucket of soap water. We tie them to a string, we dip them in, and then you'd be able to see the faces on what you created. It was really cool. We don't get to do that kind of stuff a whole lot often in math because there's just really not the opportunity to do that. But what ended up happening, I told the students, I said, don't chew the gum that you're dipping into the soap water. I've got gum over here that's fresh. I'll let you have it. This is for the activity. And guess what happened? They started chewing the soap gum, and people were trying to blow bubbles, and yeah, it was funny. It just kind of reminded me of that. So yeah, the adventures of a teacher. Okay, actually, in that same class, kind of just to give you a kind of idea about how my first year as a teacher went. When we were dealing with protractors and measuring angles, dealing with circles, things of that nature, I had a set of those old-fashioned metal compasses. You know what I'm talking about? The ones that have the nice fine point on them. We had to stop using those after a day because I had students stabbing each other with the compasses. Yep. So we had to go to the nurse. I mean, there was actually quite a bit of blood, but it wasn't out of malice. They thought it was funny. So yeah, I mean that's pretty much how it was. They were like, so. That was my first experience with teaching this material in Lubbock High School. But that was a very long time ago. So it's okay because all those people are adults now and out in the real world. So there you go. There you go. Okay, so what are we doing now? So now we're going to go ahead and continue. Now we're going to move on to area. Perimeter is very easy. If you have any questions, let me know. But depending on the formula you're going to use depends on the shape that you're given. So how do we find the area of a rectangle? Length times width. Okay, so let's see. Marissa, I need the area of a rectangle 4 by 8 centimeters. Okay, so 32 square centimeters. Okay. Alejandra, I need the area of a rectangle with side lengths 2A by 3A meters. Now that's part of it, but A does help me represent. Now we don't know what the value of A is. So what would 2A times 3A be? Squared. So 6A squared square meters. Is that okay? Everybody okay with that? Okay, just multiplying the sides using those exponent rules like you had in algebra. And then finally, let's see. Emily, I need the area of a rectangle 5 by 16 centimeters. Okay, so 80 centimeters squared. There we go. Okay, and what's the area of a triangle? Okay, 1/2 the base times the height because it's always half of a parallelogram. And the parallelogram is just base times height. So let's see here. Okay, 3 times 2 divided by 2. Well, that's easy. That's just 3 square centimeters because you don't even have to multiply. The 2's are going to cancel, right? Now this one is a Pythagorean triple. It's a 3, 4, 5. So base times height, and it doesn't matter how the triangle is oriented, as long as you have the perpendicular segments is what you're looking for. Like in this one, the height has to come from the highest vertex. Okay, so 3 times 4 divided by 2, 6 square centimeters. There we go. All right. Good, good, good. See, we're moving through this really quick. 3A. What was the area of a parallelogram? I just said it a second ago. Okay, base times height. So let's see here. How about Evelyn? I need the area of a parallelogram where the base is x plus 2 centimeters and the height is x centimeters. There we go. Go ahead and distribute across the x plus 2. So x squared plus 2x centimeters squared. Okay. And, just cute characteristics you'll want to remember about parallelograms. Opposite sides are always what? They're always parallel and congruent. There we go. What do we know about adjacent angles? They're going to be supplementary. What about opposite angles? They're going to be equal. They're going to be congruent to each other. Okay, good. Very good. All right. So let's see here. How about Michelle? I need the area of a parallelogram where the base is b meters and the height is 2a meters.
2ab meters squared.
There you go. 2ab square meters. Perfect. And we mentioned it in here before when we talked about linear functions. When you see a diagram that has these darkened triangles on them, that tells me what? That means those are going to be parallel to each other. There we go. So we're talking about a trapezoid. Here it's calling it trapezia. Okay, I personally have never heard it called that. But what's the area of a trapezoid? What's that? There you go. Okay. So I always write mine a little bit different. I always take half the height times the sum of the bases. Base 1 plus base 2. And I think even the formula here is a little different. They may use A and B. Okay. But half the height times the sum of the bases. All right. So let's see here. I want to take half the height. Okay. So the height being 5, 2 times the sum of the bases, 8 plus 6, 14. So really I'm looking at a 2.5 times 14, which would give me 35. So 35 square centimeters. Okay. Good, 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 good. Then we have another trapezoid right here. Okay. So height being 6, so half of the height times the sum of the bases. Now this one here, 5.8 plus 4.2, 10. Okay, so how many square centimeters are we looking at? 30. Okay, questions. Easy, easy, right? Okay, nice, 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 nice. Okay, good. Now let's get to circles. Okay, these are the problems that really get around. Okay, what number are we on? 5. Find the area of a circle with a radius of 5 centimeters. Okay, so Araya, what was the area of a circle? Oh, you're close. Pi r squared. There we go. So the area of a circle, pi r squared. Okay, so here all we're looking for is pi times 5 squared. So 25 pi. Let's see here. Let me go ahead and get rid of this. So 25 pi. What should I get when I push enter? Okay, 78.5. Perfect. 78.5, and then square centimeters. Okay. Now we're dealing with B. Now it does give me the diameter, but that's a quick fix. What's the radius? Okay, 4.8. So the radius is equal to 4.8. So we're just looking for pi times 4.8 squared. Okay. So again, pi. Okay, parentheses 4.8. That's not what I meant to do. Parentheses, that's not what I meant to do. Okay, 4.8. Let's square that. That's what I meant to do. So I'm getting 72.4. Okay. 72.4. And that's square meters. Okay. Okay, now this one is interesting. Find the area of this sector. Okay, would anybody want to help me out with this one? Okay. That's exactly right. Okay. So these are one of the problems, doesn't necessarily anybody needs to come up to the board. Does anybody want to come up to the board? No? Carolina, I mean, you did a great job answering that question. No, she's okay. All right. So we know this is a quarter of the circle because of the right square that we have here. So she's absolutely right. Pi times 81, so pi r squared, would be the area of the entire circle. But we want to go ahead and divide that by 4 because we only have a quarter of it. So who's already taken care of that for me? Okay, Caroline, what'd you get? 63.6 square centimeters. Okay. Now this one here, it's not a right triangle. So it depends on how you were taught this back in the beginning. Some people were taught to create a proportion. There's specific formulas you can use for the area of a sector. What I like to go ahead and do is put the measure of your central angle over 360 times pi r squared. Because taking that ratio of the central angle created in your sector to 360, that means you're taking a portion of the area. Okay, so in this case here, what I do is take the 120 out of the 360. And everybody's okay where I'm getting the 360, right? Okay, because everything comes full circle. I'm on fire today. Okay, and then pi r squared. Okay, so in this case, it would just be x squared. Okay, so we don't know what x is, so we're only going to be able to go so far with this. But what is 123/60? That is 1/3. Okay, so I would say the only thing we could do is go ahead and say pi x squared divided by 3, or x squared pi divided by 3, or however you wanted to go ahead and write it. Oh, and I don't want to forget meters squared. Okay, how we doing? Everybody's okay? All right, and I think that these are the last problems, are they not? Yeah, there we go. Okay, so I'll tell you what, we'll go ahead and do one more. Then I'll have, when you guys come in on Tuesday, we'll just finish up the other two very quickly. I'll give you the remainder of the time to work on your assignment. And then the next day we'll start prisms. We're definitely not going to finish that in one day, but the faster we get through a lot of this material, the more time we have to spend on the calculus portion, but also the review. Because as of now, we have, what, 7 weeks until the paper exams? Coming up fast. Hey, Peyton, what's up? Oh, actually, yes, I can go ahead and give you a key in just a second. Okay. All right. So let's take a look at this last problem right here. Calculate the area in square centimeters of the following shaded regions if all the lengths are in centimeters. So it looks like I've got a triangle inscribed inside of a rectangle. All right. Somebody want to come on up and show me what they would do to find the area of the shaded region? Emily, you want to come up? All right. Cool.
So define the area of the triangle between 1/2 face.
Mm-hmm.
Okay. That would be 4 the area.
Okay, so the area of the triangle is 40 square units. Or it's a centimeter squared, I'm sorry. Okay.
11 times 15.
I think what would 15 times 10 be?
Would be 150.
And then just add one more.
155. Okay. And so that would be 1.
I almost said it.
155. And you subtract.
There you go. Take the difference of the two areas will give me the shaded region. That's it, 125 centimeters squared. That's it. Perfect. Perfect, perfect, perfect. Okay. Easy? Okay. Good, good, good. All right, well, let me go ahead and do this. Let me go ahead and shut it down. And I don't have a copy of it, Peyton, so I'll just put it back up on the board again. Okay. So